Hello, everyone. I am going to be helping with dosage calculations. So, let's get started. I am using the dosage calculation 3.0 dosage by weight test. All right. The first thing that you want to know when you're doing dosage calculation is to pay attention to unit conversions. Unit conversions is really the only thing you need to know when it comes to dosage calculation. I don't know if you'll be allowed um if you have to have them memorized for the test, but I'm pretty sure it's better to just have them memorized. It won't take much to get them memorized. It's pretty simple, but the first thing you want to do is get them memorized. The first one you especially want to get memorized is pounds to kilogram. So, let's read this problem and I'll show you how to answer it. A nurse is preparing to administer erythromycin ethylsuccinate. Please excuse me if I don't read these correctly. 50 milligrams per kilogram per day, PO, divided in equal doses every 6 hours to a toddler who weighs 32 pounds. Available is erythromycin ethylsuccinate suspension, 200 milligrams per 5 milliliters. How many milliliters should the nurse administer per dose? Round the answer to the nearest tenth using a leading zero if it applies. Do not use a trailing zero. All right, so the first thing that you want to do when you see these questions is read it exactly how I read it. When you see these slashes right here, it's 50 milligrams per kilogram per day. Now, one of the best things to know is the best thing to know when answering these questions is how they usually ask questions. Milligrams is usually the amount of drugs. Kilogram is usually the weight of a person, and day is day. We all know that. Milliliter is usually gonna do with how much is being administering to a person. So the first thing that you want to do is change this 32 pounds to kilograms because right here it says 50 milligrams per a kilogram. So it will be easier for us to know how many to administer if we can convert this pound to kilogram. Now, in this unit conversion sheet that I found, it says right here there's 2.2 pounds in 1 kilogram, which means for every 1 kilogram, there's 2.2 pounds. So we're going to have to divide 32 by 2.2. That equals 14.54. All right. So the next thing that you want to do is, now that we know how many kilograms that we need to know how many milligrams of erythromycin ethylsuccinate needs to go to this toddler. So right here it says 50 milligrams per kilogram per day. So that means for each kilogram, you need 50 milligrams. So we're going to times 14.54, which is the amount of kilograms that the toddler weighed, times it by 50 milligrams. So that each of those milligrams get 50 milligrams. All right. So we're going to do 14.54 times 50. And it gives 727. Now that we have 727 milligrams per day that needs to be administered to the toddler. But wait, we're not done yet. It says in this next sentence that the drug gets suspended in 200 milligrams per 5 milliliter, which means to make that simple, for every 200 milligrams that you're gonna need to give, five, oh, I'm sorry. every 200 milligrams need to be dissolved in 5 milliliters. So if we have 727, we need to find out how many 200 milligrams there are in 727 so that we can know how many 5 milliliters we need to have. So how many milliliters we need to have. So we're going to do 727. We're going to divide it by 200 so we can know how many milligrams, 200 milligrams there are in 727. And that equals 3.635. Now we're going to take this number, because that's how many 200 milligrams there are in 727, and times it by 5. We're going to times it by 5 because every 200 milligram gets 5 milliliter. So times it by 5, and that equals 18.175. So here it says it's going to divide in equal doses. Where's this? Every 6 hours to a toddler. So we all know there's 24 hours in a day. So every 6 hours, that leaves us with 4 times in a day. So you divide 18.175 by 4 so that it can be equal doses. And that gives us 4.54. It says right here that we're rounding the answer to the nearest tenth. So the correct answer should be 4.54 milliliters. Let's see if I'm right. Yes, 4.5 milliliter per dose. All right. A nurse is converting a toddler's weight from pounds to kilograms. If the toddler weighs 17 pounds and 9 ounces, what is the toddler's weight in kilogram? Round the answer to the nearest whole number. Use a leading zero if it applies. Do not use a trailing zero. All right. So the first thing that we need to know, this question is a little bit easier because it tells you what you need to do. You need to convert the pounds to kilograms. So, well, right here we have pounds and ounces. So by now, everybody knows that there's 16 ounces in 1 pound. Obviously, 9 is not 16 and it's less than 16. So we need to know how many pounds are in 9 ounces. And to do that, we're going to divide 9 by 16. 9 divided by 16 gives me 0.5625. Now, just to be clear, the reason that we're dividing 9 by 16 is because 1 pound is 16 ounces. And since we have less than a pound, we're going to get a zero less than 1 of a pound. So that's why this answer is correct. 0.5625. Now we're going to add that to the 17 pound. So we're going to get 17.5625. So this is how many pounds that the toddler is. Now we need to convert that to kilogram. In the unit conversion, it says 2.2 pounds equal 1 kilogram. So that means for every 2.2 pounds in this 17.5625, there is 1 kilogram. So we have to divide 17.5625 by 2.2. And it gives 7.98. Now it says to round the answer to the nearest whole number, which means no decimal point, which gives 8. This one was a little simpler, not too complex. All right, I'm not going to do this one. All right. A nurse is preparing to administer amoxicillin 30 milligram per kilogram per day, PO, divided in equal doses every 12 hours to an infant who weighs 5.5 kilograms. Available is amoxicillin suspension, 125 milligram per 5 milliliters. How many milliliters should the nurse administer per dose? Round the answer to the nearest tenth. Use a leading zero if it applies. Do not use a trailing zero, which means that we're going to have one number after the decimal point, we could have a zero in the front, but no zeros at the end. That's what a trailing zero is. A zero at the end. Leading zero is the zero in the 0.5 or whatever. All right. So right here, the infant weight is already in kilogram, which makes it easy for us. So it says you should administer 30 milligrams per kilogram. Since we have 5.5 kilogram, we need to multiply 30 by 5.5 so that we can know how many milligrams is going to eat this toddler, this infant. 5.5 times 30. It gives you 165 milligrams. All right, so now it says in the second sentence, it's going to suspend 125 milligrams in 5 liters. So that means you need to find out in this 165 how many 125 milligrams there are so you can times it by 5 milliliter because each 125 milligram needs to be dissolved in 5 milliliters. So we're going to take 165 and divide it by 125. And that gets us 1.32, which means we're going to times this by 5. And that's going to give us 6.6 milliliters. Now, the PO is divided in equal doses every 12 hours. There are 24 hours in a day, so every 12 hours is twice a day. So we're going to divide this 6.6 by 2. 3.3, which means 3.3 milliliters. Let's see. Correct. Now, I do want to say I don't look at these because it's just too many words and it's too much for me. So, but you can go ahead and look at these explanations to see if they help. So, as you can see, as we're doing these these dosage questions, the most important thing is to look at the units. The units are the most important part. The goal at the end of the question is so that all your units align. You want them to align so that if this was in pounds, you can convert it to kilograms. If it was in ounces, you can convert it to kilograms so that it can match with this. So then you can give a milliliter amount at the end. So let's do this question. A nurse is preparing to administer tobramycin 2.5 milligram per kilogram IM to a preschooler who weighs 20 kilogram. Available is tropomyosin injection 40 milligrams per milliliter. How many milliliter should the nurse administer per dose? Okay, rounding to the nearest tenth. All right, again, first thing that we want to do is make sure that this weight corresponds with this unit, this weight unit corresponds with this weight unit, and it does. So we're able to proceed. No conversions need to be done here. So what this is saying is 2.5 milligram per kilogram of a person. So since there are 20 kilograms, we need to times it by 2.5. So 2.5 times 20, and that gives 50. All right, so right now we have 50 milligrams. We just converted this timesing 20 by 2.5 to 50 milligrams because we're trying to find out how many milligrams are we even giving to this preschooler at all. All right. So now it says available is tropomyosin injection 40 milligrams per milliliter. So we want to know how many milliliters we are going to be giving to the child. So we are going to divide 50 by 40 because we need to know how many 40 milligrams are in this 50. So we divide by 40, and we have 1.25 per milliliter, which means that since there is no milliliter number here, it would be 40 milligrams per 1 milliliter. So it would be as if it's 1, which is still going to give you 1.25. How many milliliters should the nurse administer per dose? Since it doesn't give any time or how many times it's going to be administered, we're going to go ahead and put 1.20. Oh, wait, hold on. Not 1.25 because it does say to round to the nearest tenth. So I'm going to go with 1.3 and see if that's correct. That's correct. All right. So this one was a little simpler, but now I'm going to try and find a hard one. All right, let's do this one. A nurse is preparing to administer potassium chloride 5 MEq per kilogram per day PO divided in equal doses every 6 hours to a child who weighs 64 pounds. Available is potassium chloride liquid 40 MEq per 15 milliliters. How many milliliters should the nurse administer per dose? Round the answer to the nearest tenth. Use a leading zero if it applies. Do not use a trailing zero. All right. First thing again, we want to make sure that this weight unit conversion, this weight unit is equal or corresponds with this one, and it does not. This is in kg, kilogram. This one is in pounds. So we need to convert this 64 pounds into kilograms so that we can know how many potassium chloride is going to be given per kilogram. First thing that we want to do is convert this 64 pound to kilograms. So now we know that, like this sheet says, let me zoom in a little. 2.2 pounds gives you 1 kilogram, which means we need to divide 64 by 2.2 because we need to find out how many 2.2 pounds are there in 64. So 64 divided by 2.2, and that gives 29.09. I'm only going to round to 2 decimal points because at the end we're going to have to get to the nearest tenth anyways, and I don't want to round too much and the answer be off. So 29.09. All right, so we have 29.09 kilograms. That's how much the child weighs. 29.09 kilograms. Now it says we're supposed to administer potassium chloride 5 MEq per kilogram. Since we have 29.09 kilograms, we need to times that by 5. We're timesing it by 5 for each kilogram so that each kilogram can get that 5 right here. So 29.09 times 5. And that gives 145.45 potassium chloride that needs to be administered. So now it says that for every 40 potassium chloride MEq, it needs to have 15 milliliters. So we need to find out how many 40 MEq is in 145.45. So to do that, just like the others, we're going to divide this number by 40. All these problems follow the same format basically. So after you've seen me do a couple of these problems, by the time you get to the test, you should be able to do these. 3.64 roughly. So we need to times that by 15 milliliter. And the reason we're timing it by 15 milliliter is because we needed to find out how many 40 was in that 145, and we did, and that answer is 3.64. Let me write that out. 3.64. So now we need to times that 3.64 by 15 milliliters. So we're gonna times it by 15, and that gives us 54.6 milliliters. Now, never forget about the time. It needs to be divided in equal doses every 6 hours. So like I said before, if there's 24 hours in a day and we're doing it every 6 hours, 24 divided by 6 gives you 4. So we're going to divide this by 4 because it's going to be administered 4 times a day. And it gives you 13.65. It says round to the nearest 10th, so 13.7. Oh, they went with 13.6. Oh, wow. I went with 13.7, but yes, same diff, same format. All right, so now I'm gonna do so. This one is complex because we are converting. Okay, let me read the problem first. A nurse is preparing to administer nitroprusid, I'm guessing, 7 micrograms per kilogram per minute by continuous IV infusion to a client who weighs 63 kilograms. Available is nitroprusid 50 milligrams in 250 milliliters, dextrose 5% in water, D5W. The nurse should set the IV pump to deliver how many milliliters per hour? Round to the nearest tenth. All right. The first thing that we have to see is the weight unit is the same, but the mass unit of the drug is not the same. This is micrograms, this is milligrams. So we have to eventually convert this microgram to milligram. But first, it says 7 micrograms per kilogram. And since we have kilogram right here, we're going to times 63 by 7 so that each of these kilograms can get 7 microkilograms. Excuse me. So we're going to do 63 times 7. And the answer is 441 micrograms per minute. So now what we need to do is convert minutes to hour and micrograms to milligram. So first I'm going to change the microgram into milligram. And the way that I do this, even though it's not on my conversion sheet, but I know that milli means mille, which in French means 1,000, which means I'm gonna have to divide this by 1,000. So I'm gonna divide the microgram by 1,000. Ooh, hold on. 441. 401 divided by 1,000, and it gives me 0.441 microgram. Now to convert it to minute, we know that there's 60 minutes and 1 hour, so we're gonna times this by 60. And it gives us 26.46. Now it is in milligram per milliliter. So it says available in nitroprusid is 50 milligram and 250 milliliters. So we need to find out how many 50 milligrams are there in this 26.46. Since 26.46 is less than 50, we're going to get a decimal less than 0. So divide by 50. I said less than 0, I'm sorry, less than 1, 0.5292, and then we're going to times that by 250 milliliter, because the amount of 50 milligrams that there was in that number, we would need to put 250 milliliters. So we times that by 250, and we get the answer 132.3, which is correct. Now I want you guys to pay attention to how it has a percentage right here. That's just to throw you off. It has nothing to do with the question. That's just to trick you, to make you see all these numbers and get frustrated and flustered. Always pay attention to that because they're mean and cruel. Anyways, next question. A nurse is preparing to administer potassium chloride 400 MEQ, I don't know if that's how you say it, but whatever, to infuse over 4 hours to a client. Available is potassium chloride 40 MEQ and 100 milliliters, dextrose 5% and 0.45% sodium chloride. The nurse should set the infusion pump to deliver how many milliliters per hour? Round to the nearest whole number. Use the leading zero if it applies, no trailing zero. All right. So you're gonna need to infuse 40 MEQ over 4 hours. And whenever there is 40 potassium chloride, 40 MEQ, it needs to be dissolved in 100 milliliters. So this question is a little bit simpler because it kind of made it easier for us. These are the same right here, 40 MEQ, 40 MEQ. So that's easy. So we just need to get how many. So 40 MEQ over 40 MEQ. Oh, excuse me. There is one 40 MEQ in 40 MEQ. 40 divided by 40 gives you gives you 1. 1 times 100 equals 100 milliliters. Now they're going to infuse it over 4 hours. So divided by 4, and it gives you 25 milliliters per hour. Let's see if that's correct. That's correct. Now, I feel like I went over that really quickly, so I'm gonna elaborate a little bit more. All right, this was the first time I was doing this question, so I wanted to be sure I was correct too. So the nurse is going to administer 40 MEQ to a client over 4 hours. So this is the total amount that needs to be administered, 40 MEQ. Now it says that available is 40 MEQ and 100 milliliters. Remember I said don't pay attention to these because they're trying to throw you off? Forget those. Don't even really look at the drugs. Look at the numbers. So we need to do 40 MEQ and 100 milliliters. So we need to know out of the 40 MEQ we have, how many 40 MEQs we have, which is 1. So for every 40 MEQ, it's going to have 100 milliliters. So if there's only one 40 MEQ and 40 MEQ, we times that by 100, and 1 times 100, 1 times 100 is 100. So now that we know how many milliliters there are, remember the nurse is setting the infusion pump to milliliters per hour. Since it's going to infuse over 4 hours, we need to divide 100 by 4 so that we can get how much should be infused over 4 hours, and that's per hour. Because remember, that's what the little slash means, per milliliter per hour. So 25 milliliters per 1 hour, which gives you 25. All right. You should be proud of yourself for doing questions like this. All right. A nurse is preparing to administer 0.9% sodium chloride. Sodium chloride. 1,200 milliliter IV to infuse over 6 hours to a client. The nurse should set the IV pump to deliver how many milliliters per hour routed to the nurse. Okay, to the nurse whole number. So we're going to need to find milliliter per hour. That's how our answer should be found. So this is the amount of milliliter that is given. This is the amount of hours that it is. So now we need to find out how many milliliter per 1 hour. Honestly, this is probably the easiest question we've done today. We just need to do milliliter over an hour. ML over HR. 1,200 over 6. Divided by 6. That gives you 200. Let's see if I'm correct or if I'm wrong. That's correct. Now, just for me to go over it one more time, the reason that I did this, again, do not pay attention to these. These are here to confuse you and put a lot of wording in. The nurse is administering 1,200 milliliters of IV over 6 hours. You want to know how many milliliters per hour? That's just a simple 1,200 divided by 6. So you can get how many milliliters per 1 hour. All right. A nurse is preparing to administer packed red blood cells, 280 milliliter IV to infuse over 4 hours to a client. The nurse should set the IV pump to deliver how many milliliters per hour? Again, this is just like the last one. Try this one on your own. Pause the video and try it on your own, but it should be very simple. All right, so if you did 280 over 4, you're correct because it is milliliters per hour. This is one of the simple ones. They'll probably not put much like this. All right, here's an interesting looking one. A nurse is preparing to administer 0.9 sodium chloride. Okay, a nurse is preparing to administer 300 milliliter IV over 30 minutes to a client. The nurse should set the IV pump to deliver how many milliliters per hour round to the nearest whole number. All right. This whole number means no decimal point. I don't know if I said that before, but yeah. All right, so we have the milliliter, but we have it in minutes. We need to convert this minute to hour. How are we going to do that? We know that there is 60 minutes in 1 hour, so we need to take 30 and divide it by 60 to see how many hours is in 30 minutes, which we know is going to be less than 1. And if you're quick with it, you know that 30 minutes is half of an hour, which would be 0.5 of an hour. But for those that don't know, it's okay. That's why we're here. We're learning. 30 divided by 60, 0.5, excuse me, 0.5 of an hour. So we need to do 300 milliliter over 0.5 hours, or 0.5 of an hour. 300 divided by 0.5 gives 600 milliliter per hour. Now, a lot of you may be saying that's not possible because we're only starting out with 30 milliliters. Well, the question is, how many are we giving per an hour? Since you're only going to be giving 300 milliliters per 30 minutes, I think we can infer that there's going to be 300 left over. So we're not going to be using all 600, but if we were to set the pump to deliver per hour, we would have to give 600 milliliters per hour. So don't fall for this trap of where, but it's bigger than this. Yes, it is bigger, but this is in minutes, this is an hour. And we're not doing the full hour if we were to do it. All right, let me see if there's any harder questions. This is kind of like the first problem. Let's see if there's any other different kind. Maybe this one. Let me see though. I'll come back to 12. Okay, it pretty much stays the same, I'm guessing. Excuse me. All right. A nurse is preparing to administer amiodarone 0.5 milligram per minute by continuous IV infusion. Available is amiodarone 900 milligram in 500 milliliter. The nurse should set the IV pump to deliver how many milliliters per hour, which means, oh, we're rounding to the nearest tenth, which means we're going to be converting this minutes to hour. Not too difficult. So we know that we're administering 0.5 milligrams per minute. So we have 900 milligrams. So we need to do, wait, hold on. I'm sorry. We don't have 900 milligrams, but every 900 milligrams is in 500 milliliters. So we need to do 0.5 divided by 900. Excuse me. 0.5 divided by 900 is 0.0005. Okay, we'll stick with that. 0.00056. We times that by 60 to get it into minutes. Oh, hold on. 0.5 divided by 900 times by 60. Oh, excuse me. 0.033. Okay. Now, if we times that number by 500, because each 900 milligram is in, it's gonna get 500 milliliters, times by 500, that gives us 16.60 or 16.7. I know the rounding may be off because I didn't really round this time, but it should be around here 6.6, 6.7, 6.8. Yeah, let's see if I'm correct. I'm correct. Now, I did want to say, because I don't know if I don't remember if I said, but the reason I times by 60 is because right now it's 0.5 milligram per minute, and we need to get it to hour. there's 60 minutes and 1 hour. So when we are given minutes and we need to convert to hour, we multiply by 60. If we were given hour, needed to convert to minutes, we would divide by 60. Hope that's understood. So yeah, that's basically it. I did want to say, if anybody's wondering what qualifications I have to do this, I am not in nursing school, but I am a pre-med student. I have taken college algebra, pre-calculus and trigonometry together, calculus 1, calculus 2, statistics. Yeah, I've done basically it all. I've done it all, so yeah. All right. If I had any advice to give to you guys is memorize some of these pounds to kilograms, milligrams to grams, micrograms to milligram, kilograms to pounds, ounces to pounds, those that you see constantly, write them down, have them memorize. And then the second advice that I would give to you is always look in the question to see what the ending result is going to be, because it could be very simple as just putting the milligram divided by the hour or something like that. Always remember to pay attention to if it's in minutes or hours, because they're gonna try and trick you like that. And also be careful with these extra numbers right here, with these percents, where they just add extra numbers so that it looks like a whole bunch of numbers and they don't even all need to be applied to the question. So bye.